out there on Facebook or YouTube land. Thank you for joining us for another one of our KdVS Foundation webinars. Again, the main purpose is really just to give people some updates on some of the really cool, exciting research, clinical research that's being done in the field of Koolen-de syndrome. Today, as you can see, we already have her slides up, but we have the honor of having Dr. Rajuta Wilson present to us today a little bit about the work that she's doing in chromatinopathies, and Koolen-de is one of those. Dr. Wilson is an assistant professor in the Department of Pediatrics and Psychiatry at UCLA. And she's just started fairly recently this project that involves looking at and characterizing disorders that have a lot of overlap with Koolen-de syndrome, which is why we are have asked her to speak to everybody here today. So, Dr. Wilson, I am handing over the speaking baton to you.
Thank you very much. Thank you for that great introduction, Anna. Thank you, Ashley, and to the entire foundation for having me here today. Thank you for those who are live and those who will end up at some point, hopefully watching this. I really appreciate your time and attention. And before I dive in, Dr. Pfalzer gave a great introduction of me, but I want to tell you just a little bit more about me, who I am, to kind of get a sense of what I do, why I'm doing this. So I am a pediatric neurologist, and I have specific subspecialty training in neurodevelopmental disorders and neurogenetic conditions. So what does that mean? After my pediatrics training, my pediatric neurology training, I took additional time here in a 2-year fellowship to work at our Center of Autism Research and Treatment, which is a sort of, outstanding center in the sense that we have phenomenal researchers and world-renowned researchers in genetics, in behavior, in autism, in intervention. So I came here to train both as a clinician and as a researcher, and I am both of those things. I am a clinician. I do have a clinic where I see patients primarily actually with what we often term now as genetic neurodevelopmental syndromes, or individuals who have genetic conditions who also have global developmental delays, autism, ADHD, among other things like epilepsy, for example, or cognitive difficulties, which I often see and treat and manage. And then I also see other things. I also see individuals without genetic conditions. And although I'm a pediatric neurologist, I often see individuals who are young adults, just because of the paucity of providers out there to care for these individuals. So I have many, patients that I'm treating who have genetic conditions through adulthood. And then if needed, I'm often trying to find an avenue to connect them with adult providers that might be able to better help their care and understand how adult conditions might manifest. And I'm a clinical researcher. So the work that I do involves human subjects, participants that come into my research lab or remotely, like we'll talk about today. And sort of my primary focus, which I'll give you an introduction, is really the motor domain, right? Or maybe more specifically, atypical motor development or motor challenges, motor differences, motor impairments, motor delays. And I'll speak a little bit as to why I work in that area, and how motor really provides an infrastructure to so many things we do in life, how we develop language, how we develop spatial perception, how we engage with the world, and how we develop social communication. So although that's my focus, we don't look at that in isolation. We really think about how that affects the individual as a whole and what that can tell us about other areas of behavioral and psychiatric development. I've worked with other family foundations. I really, really appreciate the opportunity to do that. That's been really the highlight of my work. And what I've kind of sort of dedicated my life to is better understanding these conditions and how we can best support them. So really the goals of our research is how can we develop therapies or interventions that can support these individuals by some of the information that we collect. Right, with that, I'll go ahead and dive in a little bit more. Just want to note my disclosures, which I think are important. I do have funding from the National Institutes of Health, from HRSA, from the Simons Foundation, which is funding the study that I'll be speaking about today, from the Autism Science Foundation, and actually from the United States Tennis Association. So I won't speak as much about that today, but a large portion of my work actually looks into better understanding how adaptive sports can help motor function and support many other areas of quality of life for the individual with neurodevelopmental and genetic conditions and for the family. We actually helped start a dance program here in 2019 for individuals with intellectual and developmental disabilities. So feel free to check that out on my website as well. So let's talk a little bit about why I'm focused on motor function and the importance of motor function. So as I sort of mentioned or alluded to, motor development plays a very crucial role in driving many other cognitive processes. So what does that mean? So in early childhood, right, infancy through childhood, as children and infants learn how to roll, how to sit, how to crawl, how to walk, it opens up their world for different avenues of object exploration, for environmental exploration, for engaging with caregivers and peers, which really lays the foundation for things like language development, social communication, understanding spatial depth and awareness, which lays the foundation for how you develop other cognitive processes and how you learn from the world. Motor challenges or delays or impairments are highly prevalent and often one of the first signs of atypical development in many neurodevelopmental disorders, like autism, for example, and in many genetic conditions who already also have neurodevelopmental delays. So we can imagine then if motor delays are prevalent, they can also be affecting many other areas of development. From sort of a study perspective, motor development can be observed and measured over time, which is important to think about in early childhood that we can use tools to actually better give us an understanding of these areas, unlike potentially maybe some other tools in early life are maybe harder to proxy, social communication, for example. And motor function can serve as a target for intervention. So as many of you probably know or have your children or others, family members participate in physical therapy, occupational therapy, we have interventions for motor function. And my hope is that it will not only improve motor development, but all these other areas that motor delays can impact, like language. So let's talk a little bit now and dive into how motor delays kind of present in genetic conditions, because they're highly common in genetic conditions. And so this one study in 2021 really leveraged large data sets. So from Simon's Searchlight, some of you might be aware, from the Spark data sets, they also use normative data. And what they really looked at were sort of what was reported in these data sets, which are milestone delays, right? So I'm going to focus on motor milestones here. And if you take a look at this graph, you sort of see in the first line is normative data. Second is Spark, which really what they're ascertaining here are individuals with autism without a genetic condition. And then you see these different genetic diagnoses in which we don't see Koolen-de here, but these other genetic syndromes that might have some overlap. And kind of the takeaway from what you see here is they looked at these domains, sitting, crawling, walking, single words, combined words, and looked at sort of whether they're on time, whether there was a 6-month delay or greater than a 6-month delay. And ultimately what they found were that individuals with genetic conditions more likely exhibited delayed attainment in these milestones compared to what we often call idiopathic autism or autism without a genetic condition. And this is particularly in motor. But what they noted here was in future studies, rather than just examining sort of the milestone or the age of acquisition of these milestones, it's really also important to observe the quality of these milestones. Because just because you obtain gait or you start walking, even if it's at a later age, it could look very different from someone else that's walking. And that's a lot of what my lab has looked at as well in a paper we recently published showing that, particularly in autistic toddlers, that all of them actually had the sort of what we consider a normal age of onset of walking, so in the typical range, but many of them had very poor qualities of gait, namely being slower pace. And that can affect the individual as well. So it's important to note that these delayed milestones exist, but once you achieve that milestone, knowing that the way you do that, the way you walk, the way you move could be fundamentally different and affect your overall quality of life. So diving to that a little bit more. So we also know from genetic studies, studies of individuals with genetic syndromes, that it's related to having a motor delay is related to having a higher likelihood of a genetic diagnosis. So in this first paper that I show here, identification of developmental and behavioral markers associated with genetic abnormalities in autism, many of these are autism focused because many of these data sets were particularly looking at genetic syndromes associated with autism. And we'll talk about that a little bit in the next slide. Like, how does that fit into Koolen-de, for example? But here in this first paper, what they found was for every 1 month delay in walking, increased your likelihood of having something called a copy number variant, right? A deletion or a duplication, which we know is affected in Koolen-de syndrome by about 17%. So kind of gives an idea or some information, particularly in supporting genetic testing for individuals at an early age that might present with more profound motor or language delays. So we also know there's higher rates in earlier presentations of motor challenges. I've sort of noted on that. But there's also been studies showing that these sort of motor challenges are more uniquely associated, perhaps with language and communication and autism diagnoses in individuals with genetic syndromes compared to those who may not have. And this was actually one area study that kind of really launched me into this area of research. And I highlight this paper, Identification of a Distinct Developmental and Behavioral Profile in Children with Duplication 15q Syndrome. This was led by Dr. DeStefano, the senior author, Dr. Juste, and I entered sort of my fellowship and research really thinking about this study where they highlighted and showed that although kids with duplication 15q syndrome, which is highly associated with hypotonia, epilepsy, and global developmental delays, although in this study, when they used a sort of gold standard measure of autism, these individuals met autism criteria, they showed sort of unique strengths in areas of social communication, an area that we measure when diagnosing for autism, that weren't contingent or related or dependent upon motor ability, right? So being able to smile at somebody, elicit a smile at somebody, or have that social interest or social engagement was not as affected as maybe things that require more motor mobility, like looking over at somebody or walking to somebody to socially engage in them. And so in thinking about the fact that perhaps these motor challenges in individuals with genetic conditions could really shape the way they socially communicate or even their language communication with other individuals. And so let's talk a little bit about sort of the context of Koolen-de syndrome, which many of you are experts in, either personally as researchers, as clinicians, as family members, as caregivers, and some of, on the clinical side of which I've had some exposure, frankly, not a large amount of exposure given sort of the rare occurrence of this condition. So what I've seen in the clinic, but also what I've seen read in sort of research studies that really relate to what we'll talk about today. So of course, in Koolen-de syndrome, as many of you probably know, early sort of neonatal and childhood hypotonia has been well described, or low tone in other words. And low tone often characterized by sort of what we think about is, not being able to maybe generate the same speed in walking, not sitting on time. Your postural control is more difficult. Tone can also affect how easy it is for you to sort of point and gesture, or maybe access an augmentative communication device to be able to touch that. Also, they've noted that developmental delays, including fine and gross motor delays, but overall, sort of the literature honing in that this is the most sort of prominent when we think about delays are speech and language delays. And this paper that was of really interest to me as I read about it, as I was preparing to speak to you all, is one of the ones that I've highlighted before, the one led by Morgan et al. In the European Journal of Human Genetics, that particularly looked at sort of the relationship of kind of communication as it's related to oral motor praxis and hypotonia. So knowing that these sort of signs of hypotonia or these speech and language delays could be associated to having lower oral motor tone. We also know that epilepsy is present in up to 33% of individuals in the last gene reviews that I looked at. And we know from other studies of genetic conditions, both of what I've done and others, that epilepsy can impact your motor function, your cognitive function, your language function. We know that adaptive skills can be affected in individuals with Koolen-de syndrome due to impaired motor function. So walking, getting dressed, brushing your teeth, writing, right? Motor is fundamental to everything we do daily, how we get to our car, how we access the school environment. Now, what I've sort of gained also from the literature, which was of interest to me, particularly in this study led by Morgan and also this other study done by Egger, is that information, sort of more detailed information about social skills and pragmatic social interaction in Koolen-de is somewhat limited. This sort of study led by Edgar and them in AJMG, American Journal of Medical Genetics, a study of 3 adults, described actually relatively strong memory for social contextual information, appropriate emotion perception, and less sort of social features. Sorry, it looks like that got cut off there. And so kind of highlighting a relative strength in social engagement and communication. But they also note, the paper sort of led in European Journal of Human Genetics, which is a lot of what I think about, is that social skills encompass a broad range of areas beyond what has been examined in Koolen-de syndrome, which is pragmatic language abilities, nonverbal communication, right? And understanding nonverbal communication, which encompasses a large part about how we communicate with individuals, and social relations and social interests. So there aren't many studies sort of examining this component of language or communication. It is important also to note that there have been some longitudinal studies in about 45 children by Dr. Koolen, which sort of showed kind of behavioral and neuropsychiatric diagnoses, including autism and ADHD, but more can be done in this area. So now going back a little bit to motor and the research we're doing and now into the CHAMPION study slowly is, how do we typically measure motor function right now? Where you can see me doing a neurologic exam here on the right. And as a neurologist, we obviously do a neurologic examination, which entails a lot of aspects of motor function. Cerebellar signs, how somebody walks, how somebody can tap their fingers, how somebody can accurately point. We look at tone and quantify tone and strength and reflexes, which all tells us a little bit about the motor symptoms. We also often use caregiver questionnaires, the Vineland Adaptive Behavior Skills, for example, which many of you might be familiar with as a part of studies or the clinic, and I'll talk about, which is a caregiver report of motor function. We use standardized developmental assessments, and we use some standardized motor assessments. But really what I found in sort of my fellowship training and now what my research focuses on is there do remain some big gaps in how we're able to measure motor function. Really, that there are a lack of motor assessments that can be used to assess individuals with varying cognitive, language, and behavioral abilities. So these measures might be proxying motor ability, but not taking into account that that individual may not be able to understand what tasks they're supposed to be doing, or may not have the sort of strength or energy to be able to complete all of these tasks. So many of these sort of more common standardized motor assessments, these kids or individuals often have what we call the floor effect. That means they score really low, not necessarily because the motor function is so low, but because of all these other aspects of the standardized motor assessment that's expected. Cognitively being able to understand the task, having the attention to do the task. So when you hit that floor effect, it gives us very little variability in understanding what is the true motor function. And it also makes it hard to disentangle whether this is related more to poor motor ability or inability from a motoric aspect, or kind of has to do with intellectual sort of level. So our goal is really to kind of, again, going back to that original study that I mentioned, is move beyond only capturing motor milestones and skill acquisition, but more precisely measuring kind of qualitative differences in motor function, which will hopefully allow us to better understand how that drives communication, language, and behavioral development. And so my lab, my clinical research program, uses what we call quantitative techniques to better assess individuals with genetic neurodevelopmental syndromes. We use gait analysis. So you'll see here on the left, this spatiotemporal gait map that we use. We use wearable sensors, so things that often look like Fitbits or Apple Watches that we put on individuals' wrists and ankles to look at motor activity, magnitude, amount of physical activity. And what I highlight here are two sort of conditions that I've worked with in which we've done some pretty deep motor phenotyping and yielded some really interesting answers. What I also want to highlight here through that is sort of the work, I guess in other words, what I should say is really what allowed me to do this work is engaging with scientific advisory groups and parent advisory groups to engage with these individuals, better understand what are the needs and the priorities of these individuals, and hopefully tailoring our research assessments around that. Conducting the study, publishing, but then coming back to these groups to better explain what we found, what it might mean for future research, or what it might mean for these individuals. So namely Duplication 15q Alliance, the ASXL Rare Research Endowment, or the ARRE, really phenomenal individuals. And what I highlight here is a study we published using quantitative gait analysis that allowed us to better understand motor function in individuals with Dup15q and compare that to individuals with non-syndromic autism and those with typical development. And here in our gait and movement study, where we really did sort of multimodal motor assessment using questionnaires, using gait analysis and neurologic exam to better understand motor phenotypes in ASXL1 and ASXL3, or boring opitz and Bainbridge-Roper syndrome. And it allowed us also to start understanding how motor can affect other things like school functioning, adaptive functioning. So with that, we were able to make some really significant advances, which is, yet again, while I really, really appreciate the time to come and speak to you today and the engagement with Dr. Pfalzer and Ashley. So now with that background, hopefully that was kind of lays a framework or gives at least, it was important to me to give you all some science, right, behind what we're doing and a little bit about really the motivation behind it, what it's yielded to, or so far in our knowledge. Now I want to move over to the CHAMPION study. So our CHAMPION study, currently funded by the Simons Foundation, or what we call the chromatinopathies in autism, motor phenotyping and indicators of neurodevelopment study. So chromatinopathies are a group, I'll use more scientific terminology here, of Mendelian disorders caused by variants in genes that regulate the expression, the gene expression and chromatin status, right? So essentially different conditions that may affect chromatin remodeling or histone modification. And we're now learning that these chromatin modifying conditions are very commonly associated with autism, intellectual disability, and other neurodevelopmental disorders or conditions, right? We also know that many of these chromatin modifying conditions, of which Koolen-de syndrome is considered, present with a range of motor challenges and differences. So as I've highlighted, hypotonia, milestone delays, poor balance and coordination, difficulty with fine motor skills. So this gives us an opportunity. What our goals are in this study are really using both quantitative and qualitative ways to measure these motor difficulties in individuals with these conditions and better understand how they affect adaptive function, behavior, and cognition. So what I've put here is adaptive skills, autism symptoms, and language, with a goal in turn to really inform natural history studies of these conditions and clinical treatment targets and trials, among other therapies that families may have more readily accessible, right? Behavioral therapies, motor therapies, physical and occupational intervention. So now more into just the details of this study. So eligibility, for example, and what we're doing. So here I note UCLA researchers are doing a study to learn more about motor, adaptive language, cognitive, and behavioral development in children with chromatin modifying conditions. Right now, for the eligibility criteria, we are recruiting ages 1 through 5 years of age. You know, I get a lot of questions. I really do hope to extend the age range for several reasons. We're focusing on this early development area. Really, you know, in better understanding kind of early manifestations in these conditions. You do have to have a diagnosis of a chromatin modifying condition. So having a diagnosis of Koolen-de syndrome would make one eligible. We have 2 study arms. We have an in-person at UCLA visit and a virtual visit. And we do also have some funding for families to travel to UCLA. And we do have a couple of families who have made that decision in the larger California area. We've had discussions with other families located in other states, but that is an option, understanding that does take time and effort. But if there is interest from a family, we can help support that. So now let's dive a little bit more into the nitty-gritty of the assessments. And I'll talk about the in-person and the virtual. And I gave a little bit more detail here because I thought this was a nice opportunity to kind of really understand what these assessments mean, what we're looking at, right, and how they might be helpful both in this study and beyond to a family potentially. So our assessments include if you are in the in-person arm and the remote arm, but I'll first speak to the in-person direct assessments that we call that involve the child. One of the measures we use is the Autism Diagnostic Observation Schedule, which is the gold standard direct examination or a diagnostic assessment for autism. But really what I want to note that we're proxying here are social communication and areas of repetitive and restrictive behaviors. And why do I focus on that? Well, I've had many families sort of come to me, which has been really both interesting and very astute and important to say, you know, you're doing this autism assessment, but my child doesn't have autism. Or, you know, this genetic condition isn't commonly associated with autism. But that takes me back to what we were talking about in Koolen-de, right? It's not just about the goal of diagnosing autism, but it's more examining sort of social communication in a more detailed way, or maybe I would say in a different lens than just looking at speech and language delay, right? There's many aspects to how one engages. And even if that doesn't necessarily mean you meet an autism diagnosis, it perhaps might give us information that language is delayed, but also pragmatic language skills are delayed. Nonverbal communication may be delayed, and those are areas we may want to support for this individual. The other assessment, direct assessment we do is the Mullen Scales of Early Learning, which is fine motor, gross motor, expressive and receptive language, and visual reception. So all these domains of functioning that allow us to give us more detailed aspect of these different developmental domains and how they might also affect areas of like social communication, for example. From a more motor perspective, I do a neurologic examination on every individual that comes both in person, and I also do it remotely. Telehealth has really expanded. I have many ways to elicit a neurologic exam. Of course, some direct aspects can't be done. We also do gait using this pressure sensor mat that you see up here that requires an individual just to walk across it. We also collect gait at home because we can do it remotely and have a family do that. And then we use these wearable sensors. And here you'll see some younger infants and children wearing them on their wrists and ankles. These sensors look similarly to an Apple Watch. And my apologies, I actually thought I had a picture of the sensor here, but I think it's blocked by one of these other pictures. So I don't want to stop and undo that, but it looks similar to an Apple Watch. We put them in these sort of leg warmers or socks on the wrists and the ankles. And what I'll tell you is they're fairly well tolerated. Actually, they're comfortable. We put them under clothes. And what we ask is for the children to wear them during the day, all day, for 2 days in a row. They're taken off at nighttime to sleep. They can be taken off for bats. But what we're assessing from here is really seeing if we can understand what are levels of physical activity, what are more qualitative ways we can understand how these children are moving to help inform better understanding the motor profiles of these children. If you're in the remote arm, we don't do the ADOS or the Mullen, but instead we do a video observation using the CARS, which have been used for many other networks like the RDCRN, a consortium looking at genetic conditions. And there again, our psychometrists and psychologists do different things with the parent and the child to elicit different areas to look at social communication and motor behaviors. We do a developmental cognitive profile that we fill out with the parents. So those are the more direct assessments. And then we also have parent interviews and questionnaires. So we do a medical background and language questionnaire. We do the Vineland Adaptive Behavioral Scale, which is a very commonly used and widely used measure to look at adaptive function. And we do the autism diagnostic interview, which allows us again to look at areas of communication, repetitive motor, maybe restrictive or behavioral domains that we might not be able to do directly in person. So all of these combined, just again, really important kind of logistically to know, the interviews can take up to 1.5 hours to 2 hours. So it does take some time, but these are parent interviews getting us more detailed information, more what we feel is probably more valid or relevant information around functioning. The remote assessment, the video visit taking about 30 minutes to 1 hour that we split between 2 visits, the in-person taking up about 1.5 to 2 hours, depending on the child. Again, we have a lot of flexibility with the Zoom visits, like the parent questionnaires and the video assessments at home to do them at different times, evenings, very early morning for the families, and to split them up as best for the family. As a part of the study, all families receive written feedback about the child's development. So we give you scores and written feedback from our psychologist who's on the team and me, which a lot of families often may take to their therapists or their physicians. We do and have released these reports to physicians through, of course, a formalized process that would be taken, which has supported certain clinicians like developmental behavioral pediatricians to give autism diagnoses in some cases where they haven't before, or to be able to better support maybe or give information from development or developmental functioning that might be for that individual. We give up to $100 in compensation. After our assessment and after the verbal feedback is written up, I meet with all of the families either by phone or Zoom, whatever the families prefer, to give verbal feedback around what we found in the study, to answer any questions the family might have. And then what we really try our best to do is kind of think about what may be areas of therapy the child is already getting and what might be areas we may recommend based on our own assessment. Now, of course, this is research, so it's important to know that I can't give you clinical recommendations, right? And I want to be mindful of that, but I can give you recommendations based off of that report that we can talk about that may translate to getting better clinical support and help. And so more of what I mean by that is just being mindful and being very honest about the fact when medical questions are asked, I'm very happy to answer them. And we just want to make sure that I'm able to connect you with the right provider in your area if you're not in the greater Los Angeles area. If you are, we have many opportunities to get involved in our clinics here too. If you are interested in having your child participate or you would like more information, you can contact the study coordinator, Ronald Lai. You can also include me. That's my direct email there. And we have a phone number as well. That website up at the top will lead you to the study to read more about our flyer. And that QR code, if you scan it, will also take you to the study as well. We're always happy to answer more questions, get on the phone, talk more about what this might mean, what opportunities there are for remote, in-person, or traveling here. I think that's all that I have to share with you guys today. I appreciate your time. I appreciate all of the families thus far who participated in our research and allowed me to show you some of the data. I'll just show I do appreciate the individuals who have funded us to do this work. And of course, my clinical research lab, which, all of this work can't be done without all of these individuals who participate. So I'm going to go back now to this slide just so you guys can have this information. And I'm very happy to answer any questions, Dr. Pfalzer, or comment on anything that I missed.
No, I think you did a wonderful job. That's great. This is something that I think is going to be of great interest to the KdVS community. You've done a pretty good job of reading some of the recent papers that have come out in KdVS, and I have a variety of questions, but I am going to try and stare at the little chat button just so that I don't monopolize it. But I'll start off with a couple that I came up with. The first is kind of a combination of a statement and a question at the same time. So it seems like, first, it seems like there's about 10 to 20% of KdVS caregivers that say that, motor symptoms really impact their quality of life, either the family's quality of life or the individual child or young adult's quality of life. And so looking at motor function and gait specifically and coming up with better understanding that to try and do an intervention that could possibly, down the road improve quality of life, I think will be really helpful and useful for a lot of our families. And so I know that your slide was really focusing on gait, but were there other parts of motor? Can you just review again other types of the motor assessments that you do for part of the Champion study?
Yeah, definitely. So just to comment on your first statement, that's really helpful to know that families are reporting that, particularly in Koolen-de syndrome. We do hear that. I hear that in many individuals with genetic conditions. And kind of a highlight on that is that it can affect quality of life in many different aspects. But also one thing that we kind of hone in terms of, you noted on intervention or treatment, is that in the most recent paper we sort of published and put out that I mentioned, where we saw normal onset of the milestone of walking, but really difference in quality, what I noted in the paper and I really wanted to hone in on was under the IDEA Act or under, sort of therapies that are given in school, oftentimes physical therapy can maybe drop off because a child can safely access the schoolyard, right? It really has to be noted what maybe the deficits or difficulties are. And what I hear very often anecdotally in the clinic is, it's stopped, but there's still a lot of gait and locomotion and coordination and balance difficulties that my child has. And to be thinking about physical therapy outside of the school and fitting it in and the time and the support can be hard. And so one of the goals of this is better understanding many aspects of motor quality, not just gait, with the goal to support that type of data, to say there are many other areas we need to intervene or inform intervention, both of what's already available, physical therapy, or maybe perhaps hopefully new interventions that directly target for these individuals, right? So this study does more than just gait. We do gait because it's such an important part of gross motor function. And our gait variables not only just look at gait of how you walk, but also how you balance and how you support yourself. which is fundamentally often an aspect that's affected, particularly in kids with hypotonia or low tone, and tone being a very hard thing to measure objectively or quantitatively, right? So other aspects of motor that we're looking at, so in the Mullen, for example, we're looking at fine motor ability, how a kid is manipulating objects, how they're reaching for them, how they're grasping them, how they're arranging different objects. We look at spatial, sort of visual motor through being able to put together things or how they're putting together sort of different blocks or different, what's the word I'm looking for, patterns within the Mullen itself. We're looking for gross motor skills beyond gait, like walking stairs, like jumping, like balancing. The wearable sensors allow us to proxy different things, right? Sensors are largely measuring how you accelerate. So it's what you then derive from those sensors that you're looking at. And some of the things that we're looking at are overall physical activity levels, right? Those we know can be reduced in individuals with genetic conditions and motor delays, further affecting their quality of life, leading to more sedentary behaviors, for example, which can lead to things like higher rates of obesity or higher rates of what we think about other medical conditions that can be affected by being more sedentary. Some of the sensor data, which I think is important to discuss here, and I discuss with a lot of families in our call and when they first enroll, this is an aspect of our study that we're developing. We've developed these sort of wearable metrics much better in infants in my previous studies, where we've seen sort of that infants who have later developmental diagnoses kind of fundamentally move different. Their sort of underlying movement signature looks different compared to infants who don't have developmental delay diagnoses later. So part of the goal here is to extend this to older children and understand, are there fundamental differences in their movement signature, how they move throughout the day? That's a part of the study that we're still establishing, and this data will help us establish. Does that answer your question, Dr.
Yeah,
Pfalzer?
no,
Okay.
totally. I was just thinking because there's a lot of kids, we're finding that there's a lot of respiratory problems, a lot of um a lot of what do you call, a lot of kids that are diagnosed with laryngeal or tracheal malacia, problems with um post anesthesia recovery. I mean, things that all in my mind sort of focus around or hint towards there's like some really severe impairments in oral motor function. And so that's why I was trying to cue in and see like, are there any available assessments that could see how impaired are these kids? Are these respiratory problems? Are these swallowing problems? Problems after anesthesia? Are they all just related to having really weak or somehow impaired oral motor problems? And that's almost, that's more than a quarter, a little bit less than 50% of people report that in like a pretty large cohort of KdVS caregivers. So it was really surprising to me.
Yeah. I saw that a lot. Actually, I appreciate you noting that too. And I think through the literature, particularly that one study I think I highlighted from 2018 was striking to me in that area. And gene reviews I read, other that I read, was maybe less about the respiratory difficulty that you mentioned here and the tracheal laryngeal sort of difficulties also.
Yeah.
Often that we think can be related to low tone, right? A lot of these kind of manifestations of hypotonia in early infancy, more so the respiratory difficulty, drooling, for example,
Yeah.
but then kind of leading to what you mentioned where, you know, oral motor tones causing difficulty in actually production of language, right? There are assessments for that, right? Speech and language pathologists can do specific assessments for oral motor function. As a part of this study, we don't do a very specific oral motor assessment. I think that's really important and a really good one. We do expressive and receptive language assessments, and a part of our sort of visual observation, and this has come through in some of the kids that participated, we have noted that. We have noted that it really looks like some of the language ability, or as they approximate, is more affected because they have really low oral motor tone. And we've commented on that and sort of spoken to families about accessing things which could probably be very pertinent for individuals with Koolen-de syndrome. Speech therapies that specifically focus on myofascial strengthening techniques, speech therapies like prompt therapy, for example, right? So these are important aspects to consider when thinking about how oral motor tone can affect how you speak, production of speak, or apraxia of speech. So we have other ways we maybe look at that, but not a direct speech and language pathologist doing that assessment on this study. Yeah.
Yeah. Okay, I have a couple more straightforward questions. So one question that I think was either in the chat, do you need an autism diagnosis in addition to having their diagnosis of Koolen-de syndrome to be eligible for your study?
Very good question. And I'm so glad that was asked because I was remiss in not noting that. It's one of the reasons I was talking a little bit more about measurement around autism. But short answer, no, you do not need any other diagnosis other than a Koolen-de syndrome diagnosis. So purely, and if you look at the website, just to ensure again, to be even more clear in case there's confusion, if you look at the website, we have 2 or 3 different flyers. So we have a flyer recruiting individuals with chromatin modifying conditions, which is pertinent to the group I'm speaking to today. Then we do have a flyer recruiting children with an autism diagnosis without a genetic condition. And that's one of our comparison groups here.
Yeah.
And we have children who are neurotypical, also another comparison group from the motor sort of in producing maybe norms on motor functioning data we can look at. So again, to answer in such a good question, one does not need to have an autism or other neurodevelopmental disorder diagnosis to participate.
Perfect. Okay, and another question is this limited to people who are in the US? So, there's a pretty large international population, especially since you can do virtual visits.
Yep.
You limited to doing either in-person or remote to people who live in the US?
Good question. And I'll give you the short answer and then the to be sort of determined. Right now, it is limited to the United States. The reason why it's limited to the United States are some IRB considerations that we've spoken to our IRB about, our Institutional Review Board, for those, who review sort of ethical studies, coverage of sort of within the studies. Some of the logistic was the mailing of the sensors themselves. So we mail them to families in the United States to be able to do the sensors at home. That doesn't mean we can't do that internationally, but we might have to think about that differently from just a support and funding perspective. But this question has come up a lot. And understandably, there are many families outside of the US who are interested, who may not have access to the same type of research studies. So it's been on my top of the list and thinking about this study and thinking about how we might expand that. So please stay tuned, but right now it is the United States.
Yeah, no, we hear similar frustration from several academic investigators, and I haven't, making studies international is a headache for not just you, but lots of people that we have been researchers who are working on KdVS in the field of neurodevelopmental disorders in general.
Yeah.
There was one more question that someone wrote me, or either I thought of. Hold up just a second. Oh, okay. Are there any exclusion criteria other than age, and not having a KdVS diagnosis? But is there anybody? Let me rephrase that. I'm gonna ask it another way. Is there anything anyone else needs to think about to be eligible other than between the age range and having a KdVS diagnosis? Like their epilepsy is really severe, or they have some other comorbidity or some other symptom that would make them ineligible.
So the shorter answer, epilepsy is not makes them ineligible. We are taking all individuals also with epilepsy. I know that's often exclusion criteria for these studies when we're thinking about, but no. There are no other exclusion criterias otherwise. So you also don't have to be ambulatory. You do not have to be walking to be a part of this study. For those individuals, we do not do gait, but that's why we do the sensors, and that's why we do the examination of other motor abilities, because the whole goal is to better proxy motor function in different ways for many of these individuals who are not walking. There are 2 things I do want to mention here. One, in a more sort of clear way, that if your child has a diagnosis of Koolen-de but also has another genetic syndrome, in which this would be a more nuanced talk, deletion or something, where the thought is that that is more likely the presentation of certain things rather than maybe the Koolen-de. I think that would be a discussion with that family. We've come across that to just make sure we just talk through it and better understand kind of when we're enrolling this individual, what that might mean in terms of what we're saying about the presentation of the syndrome, right? And not um, uh, and being accurate about what we're measuring and what we're presenting about this condition. Oftentimes, I'll have conversations with family in terms of where a child might be developmentally when they're interested in the study, where if they're about to walk, right? And if we think in the next few months they're gonna be walking, or from a language perspective, what are sort of the communication techniques? And then we might talk a little bit about when makes the most sense within our study timeline to enroll. But I only mention that because that's part of the conversations that we may have. It is not an exclusion criteria for the study.
Yeah. Wow. Okay, so I have another question. It might seem a little silly, but what does a remote neurologic exam look like?
Yeah, that's a good question. So a lot of what we do in pediatric neurology, and this has been a conversation at the forefront, I'm pretty involved in the Child Neurology Society and the Child Neurology Foundation, you know, particularly came up during COVID, when we had to move to so many telehealth modalities. And there's so many wonderful and important parts of the neurologic exam that really require sort of hands-on being there with the individual, but there's a lot of parts of the neurologic exam we can still proxy remotely, right? And there's actually guidelines that even sort of outline, I shouldn't say guidelines, but kind of outline that these organizations have come up with to help trainees and help individuals, bless you, Anna, help individuals sort of guide that. So just kind of maybe a broader statement for many of you who probably are accessing telehealth, right, to a certain degree. And a lot of what we do in pediatric neurology is observation. We're watching the individual because we're sort of trained in better characterizing. Do they look ataxic? Do they look wide-based? Do they look low tone? So what it is I'm going to make sure that there's an opportunity that the camera gives me a full view of the child, that if they're walking, I can have them walk across the room and have them do different things. I can have them tap their fingers. I can have them reach for things. I often enlist the caregiver to do things that we do, like finger to nose, to see if they're dysmetric, for example, eliciting some cerebellar signs. So a lot of that is looking at the way they move, if the symmetry of their movement is different, if their coordination or balance or tone may look different from what I'm seeing. Things that I can't do is I can't do reflexes, right? I can't physically sort of move the child myself, but I can have a parent do that and ask, does that look more spastic or hypertone or more low tone, for example? So those are some of the things that a neurologic exam typically looks like.
Okay. So it doesn't sound like there's a whole lot that you can't do remotely that you can do in person. I I was just trying to figure out, is there a justification for us to all to try and encourage our community to fly to Los Angeles, as opposed to, doing it remotely?
Remotely. Good question. I think partly it's up the individual. Sometimes it's sort of the family, what there may be lack of access to certain developmental assessments, because we essentially do what a developmental behavioral pediatrician or a psychologist would do in a comprehensive developmental evaluation. That's kind of essentially the battery of our tests that even our clinic does. And the write-up is not as extensive as those usually are, but kind of honing in on those areas. So we sometimes have families that choose to come out to us because the wait list is very long to do those things, the access to that is low, or they're looking for maybe more nuanced support or testing.
Yeah.
I think one area that we can't do, although the remote arm, we've been felt really positive of what we've been able to get. One thing that we can't do is we can't do the direct developmental assessment, right? I can't do that Mullen assessment. And some of those Mullen assessments not only give us a direct proxy of sort of developmental milestones, but it does often help us better measure what nonverbal communication might look like for the child, because we have really novel ways or unique ways to elicit that, our psychologist and me and our psychometrist. And I think some of those nuances are missed remotely. That doesn't mean we can't get good information from the remote visit, but I've had conversations with families saying, I think this is an area, and I'm seeing that from the remote visit. I can't quite measure that as well, but here's what would be my suggestion to somebody who could do that in your area. Maybe your developmental pediatrician wants to focus that as updated testing that they're going to have, or if they haven't done that yet, to better inform supports for that child.
Um, cool. No, this is amazing. So I think I don't have any more questions, and I know we only have a handful of minutes left. So for people who are watching right now or watching the recording later, would you say the first thing to do would be to scan your QR code or go to your website to say, "Yep, I'm interested and I think my kid, has a diagnosis, falls within that age range." That's the first thing to do, and then someone will reach out to them, or would you say it's most efficient just to email your coordinator?
I
What's
think best is email the coordinator and feel free to include me. You can scan the QR code, go to the website to learn a little bit more, kind of refresh. But I'd say best thing if you have some interest or want to hear about your participation or hear more is email us.
okay?
We can get back to you and we can arrange a phone call or answer questions over emails if that's better.
Okay. Okay, we have one more question I just got. So do you have any preliminary findings from either your gait or speech assessments from even other disorders or the visits that you guys have completed already that would sort of give us an idea of the overlap in, specific features that you're seeing across chromatinopathies?
Yeah, really good question. So I would say, I think we're still early in this study. I'd say that um, I don't know if preliminary findings about features across chromatinopathies just from this study, but some from previous studies, which are in chromatin modifying conditions like ASXL1 and 3 that also are enrolled in this condition, and previous studies, some sort of common threads that we're seeing are, as I've sort of mentioned here, motor difficulties and challenges, impairments are frequent, and it goes beyond just motor milestones. And some of those motor difficulties have been areas that we've sort of measured or kind of has told us compared to other studies that maybe we don't typically look at, which is how motor affects school functioning,
Mm.
how motor affects self-esteem, how motor affects quality of life. That's what we've sort of uncovered both through parental interviews, both through some of our caregiver questionnaires and through our previous ASXL study, which one may think or intuitively a family may see, but it hasn't been well measured yet in a study to put out there for caregivers and clinicians to understand the broad impact motor difficulty can have on an individual. We've also seen a really high prevalence, particularly which falls in line kind of with what one might see in Koolen-de syndrome of hypotonia. And the fact that hypotonia can really characterize speech and language production. It can characterize accessibility to an augmentative communication device to help augment communication or language, just purely in terms of accessing, having the strength with, the ability to coordinate touching the device itself. And we've also continued to see that these motor difficulties really highlight some of the maybe autism symptoms we might characterize, just purely from the inability to maybe as quickly engage with an examiner and show what we often measure like joint attention, looking over, kind of giving someone something to engage and play, these motor difficulties often underlie that. So if we know that, thinking about if we support these motor areas, how that might help other areas. Or if we're giving an autism diagnosis or talking about social communication difficulties, really being able to maybe hopefully educate ourselves and families better that it's really a function of maybe some of the motor difficulties, or that's one major player that might not be for other individuals who have chromatin modifying conditions.
That's the perfect segue into my very last question, which is, do you need unaffected siblings? So if someone has a kid who's eligible for the study, um, do you need uh, healthy controls that are within the same age range if these families have unaffected kids, or is that not something that you need as a comparison for the study?
We do need healthy controls as a comparison study. So we're
Ah,
not specifically recruiting only, just
okay.
siblings of
Yeah.
those individuals, right, as a comparison, which we've thought about and looked at in other genetic conditions. But yes, one of the cohorts, and you'll see on the website, are healthy controls, or what we call typically developing or neurotypical controls as a part of the study. And so if
Cool.
there's interest, very happy to talk to families about that too.
Awesome. Okay, great. No, this has been fantastic. I hope that your coordinators gonna get inundated right now with lots of emails from families. This is a really active, engaged research community. So I wouldn't be surprised if you guys got several emails or clicks on your website from people watching.
Well,
So
I really appreciate that. I really genuinely appreciate this amount of time you all have given me. It's a tremendous amount of time out of your day. And to take some time to hear about what I do, what I'm passionate about this study specifically. I really appreciate the phenomenal questions that only helped really improve this presentation and hopefully an understanding of this study. And please feel free to reach out to us regardless. We have had some families reach out to us who might be in the area, who are out of the age range, but just some support in getting maybe connected to a medical center, for example. So just knowing that we're happy to be supportive in that way too. So thank you very much. And thank you, Dr. Pfalzer, and to Ashley for putting this together.
Yeah. Awesome. Thank you.
All right. Thank you, everyone.
Yeah.